Now there's carbon dioxide that is in the atmosphere. And we learned that, of course, human beings, animals, anything that breathes in oxygen in order to stay alive is going to release carbon dioxide. So it's in the atmosphere. So for right now, excluding the pollution that is in the atmosphere, we have our hydrogen, or rather our carbon dioxide atoms that are floating around in the air. And as rain falls from these clouds down and travels down towards land or water, there is a reaction that happens. And as you can see here, that reaction is carbonic acid. This is a weak acid. Whenever I refer to something as a weak acid, that means it's very easy to break certain molecules or atoms off of that acid. It can also bring in those same atoms or other atoms to reform that acid. And just a quick note, as you see here about alkalinity, a lot of people, they use the terms alkalinity and basicity, or a liquid being a base, interchangeably. They are related, but alkalinity actually refers to the liquid's ability to maintain its pH. So the example I used was, let's say I have a glass of water, the pH is 7. If I added vinegar or acetic acid, the pH lowers because there are more hydrogen atoms that are now in that water compared to OH atoms or OH molecules. Now, let's say we have our glass of water, the pH is 7, but we add something called calcium carbonate. And remember that calcium carbonate comes from chalk. So if you add calcium carbonate that's ground up, mix it in to that water, and then you add, let's say, a tea or tablespoon of acetic acid, most likely the pH of that water will stay the same. That is due to the fact that the acetic acid, the hydrogen atoms that are coming off of that acetic acid, is going to bind with some of the other atoms from the calcium carbonate, really the carbonate section. And because it binds with that, it's able to kind of pick up the slack that you've added these extra hydrogen atoms. So therefore, it ends with having the same amount of hydrogen atoms compared to not only the amount of hydroxide atoms from the water, but also the calcium that's in that water, which is also kind of a base. Now, if you want to see the reaction as far as what happens when rain falls from the clouds down into land or water body is right here. So first step, as rain, this here exists as a gas in our atmosphere, and this is the rainwater that's falling. And so when that combination occurs, you form what's called carbonic acid. Remember I said before that it is a weak acid. So this dynamic equilibrium that's happening right here, we change colors. You can't see that. So this dynamic equilibrium that you're seeing here means that the carbon dioxide and water is going to form carbonic acid, and then that hydrogen atoms are going to split off from the carbonate and form carbon dioxide and water. It's all happening again at the same time, dynamic equilibrium, and that's when rain falls from here down to our water body. Once it falls into the water body, erase this. There we go. So once it falls down onto the water body, that's when you start getting into this carbonic acid, then releasing one of its hydrogens, because remember it's a weak acid, it's very easy for this to happen. And it releases, again, because remember that water is polar, so it's going to attract, the oxygen atom is going to attract this hydrogen atom and basically strip it of it. And so it strips off, forms another weak acid, and then this too is also a weak acid, and it will dissociate or get taken off. Again, usually it's by water to form, forgot the name of it, carbonate, hello, to form carbonate plus your hydrogen atoms that are now floating in your ocean water or in fresh water, a freshwater system. And again, as a reminder, go back to yellow, all of these are happening at the same time. Remember, again, this is dynamic equilibrium. So because water or rainwater is actually slightly acidic, the pH of that is 5.65 in general, can fluctuate up and down. So if you've ever gone outside or been outside and you've said or thought something like, I smell rain, and that is because you are smelling rain, literally. You smell it coming if you don't smell it when it's falling. That's the carbonic acid that you are smelling. Now, the pH can get lower than that, right? So you'll notice here that the pH can lower to as much as 4. That's not good. That is because there's too much, use red for emphasis, there's too much carbon dioxide in the atmosphere, there's too many sulfates in the atmosphere, as well as too many nitrates in the atmosphere. A lot of this comes from pollution, from local factories, from cars. Transportation, I want to say, is the number one, or either number one or number two producer of all of these combined being released into the atmosphere. That is why for the past 5 to 10 years there have been stricter regulations in terms of the pollutants that cars can release into the atmosphere. And if you can't have your car maintained to that standard, then it fails inspection. So with that, that ends this lecture here. You do have access to the rest of the pH, or rather the water quality parameters. And so I will probably actually record those later this week so you can hear me actually talk about them, and then we'll go over those slides again on Saturday of next week. Take care, everyone. Stay well, stay healthy, and feel free to email me if you have any questions at any time.